Hi guys, this is question number 8 on page 376 in your textbook. We're still on 7.2 dot product. And this is a bit of an application question based on dot product. So the question gives us two different triangles. I'm only going to do it for one triangle just to show you the process, and then you can do the second one on your own. And it asks us which of the following is a right angle triangle. Identify the right angle in that triangle. So part A, I'm going to use the vector methods. And then in part B, it asks you describe another method for solving the problem. So I'll discuss that briefly as well. Okay, so we're given 3 points here. And I just want to point out that we know that these are points and not vectors for a couple of reasons. One, the brackets are round, and two, there is no vector sign on top of A, B, or C. So that's going to be an important distinction because we're going to use these points to make them into vectors. So we want to make sure that our notation is always clear on what is a point and what is a vector. So how do we determine if this angle is a right angled triangle? Well, if this triangle has a right angle in it, then that would mean that two of its sides were perpendicular. If two of the sides are perpendicular, then the vectors describing those two sides would have a dot product equal to 0. So first of all, we need to, and I'm drawing this as a right angle triangle. It's not necessarily a right angle triangle yet. We don't know whether it is. But just to kind of, actually, you know what? I really shouldn't do that. I'm not going to. Sorry, I'm changing that. So I'm just going to draw it as any old triangle with vertices A, B, and C, which I'm given. In order to describe the sides of the triangle, I need to find the vectors corresponding to them. And so for this side, the side between points A and B, let's call that vector AB. The sides between vector B and C, or the side between vector B and C would be vector BC, and the side between, sorry, I'm totally mixing that up. Let me start again. The side between points A and B is vector AB. The side between points B and C is vector BC, and the side between points A and C is vector AC. Okay, I think it was right that time. All right, now you need to remember how to get vector AB from points A and B. I believe I talked about this in one of my prior videos in 7.1. And so when we have a vector that goes from point A to point B, in order to find that vector, we would do the endpoint minus the initial point, which would be B minus A in this case. And so the first component of B minus the first component of A, and then the second component of B minus the second component of A. So that vector comes out to -5, 2. And now that I've shown you the process, I'm just going to quickly do the other ones in my head. So vector BC is going to be 5 minus -2, that would be 7 and 3. And vector AC is going to be C minus A, which is 2, 5. So we now have the vectors that describe the sides, each side of the triangle ABC. And what we want to know is there a right angle in this triangle? And so we need to check if any of the dot products of those sides are 0. So we'll start with AB dot BC. So vector AB is -5, 2. Dot that with vector BC, which is 7, 3. And the dot product is -35 plus 6, which is not 0. I don't really care what it is, but it's not 0, right? So we know that AB is not perpendicular to BC so far. Let's check BC and AC. BC dot AC, BC is negative, oh sorry, BC is 7, 3. AC is 2, 5. And so the dot product is clearly not going to be 0 because both components will be positive. So it's 14 plus 15, obviously also not 0. And we have one more possibility. That would be AB dot AC. And so that's going to be negative 5, 2 dot 2, 5. Looks promising. Negative 5 times 2 is negative 10, plus 2 times 5 is positive 10, equals 0. And so we do in fact have a right angle between side AB and AC. And so ABC, therefore triangle ABC is a right triangle. And angle, let's go back here, it would be angle BAC equals 90 degrees. Now, I'm not going to bother doing triangle STU. You can try that on your own if you want to practice the method. For part B, it asks, is there another method that we can use to solve the problem? We can always go back to our grade 10 methods, pre-vectors, and simply find the slope. Since we have points A, B, and C, simply find the slopes of each side and see whether they are negative reciprocals of each other. If they are, then we would know that we have a right triangle as well. And we would know where the right angle is. Okay, so you can try that on your own as well, if you wish.